On the first part of this video, we covered some typical waveforms and we extracted parameters out of those signals. We extracted information, period and frequency, so time information, as also duty cycle, which is a ratio, it's a percentage. And then we extracted information from your y-axis, maximum voltage, voltage peak to peak, and minimal voltage. On the second video, we're going to design waves. Now I'm giving you the parameters and you guys are going to design. I'm going to do 3 examples out of these 3, 6, 8 exercises that I have here. If you took Intro to Mechatronic Systems 1, you're probably familiar again with these exercises. You can do them again, or you can come up with new parameters and design your waves. The first example that we're going to do is going to be this one. So how can we design these in an effective way? So the first thing that I'm going to do is represent the waveform. I have a sine wave, so I'm going to design a sine wave without caring too much about how many cycles I do. DC offset is 0, so I'm going to design my axis that I have here, and this one goes right in the middle because there is no DC offset. This is my timing, this is my voltage. And now I have volt peak to peak. That means that from my max to my minimum, I need to have 2 volts difference. So I have 1 volt over here, minus 1 volt over here, and this is giving you the 2 volts peak to peak. And at last your frequency or your period. So I go from this point until it repeats, which is this. So I need to find this t, and I know t is equal 1 over my frequency, so 1 over 1k. I know that 1k is times 10 to the third. All right, so I can pass that power to the third to the minus 3, and I get 1 millisecond, and that's my period. All right, let's go over another example, a triangle wave. So I'm going to design a triangle wave the best that I can here. A couple of cycles, doesn't need to be a lot. Going to have a DC offset in this case. So how do I do this efficiently? So let's design the triangle wave with the DC offset of 0. So if it's 0, I design my y-axis here, which is voltage, and if it was 0, I will go to the mid part of my triangle wave as much as best that I can, and this will be my time. This is 0 over here, and then I will have volt peak to peak. So let's go and design that volt peak to peak from here to your minimum. This is your minimum, this is your max. It's 600 millivolts. So that means that I would have 300 millivolts here, minus 300 millivolts here, and this gives you your 600 millivolts. But this is assuming an offset of 0, and my offset is actually positive, 150 millivolts. That means that I'm going to shift this triangle wave up by 150 millivolts. All right. So I'm going to design my new axis over here. Oh, I apologize, this moved. I'm going to design my new axis over here. And now I'm shifting 300, my minimum value, this minus 300 is going to be minus 150 millivolts because I shift that one up, and I also shift the top of it 300 millivolts higher to 450 millivolts. And this is how your new wave is going to be designed. All right, let me go back, design these guys. The only thing that I'm missing is my frequency. So let's go over the frequency. I know that, let's just design again in blue. So I go from here to here, that's my period. And my period is equal to 1/100 Hertz. Different ways of tackling these, I can say it's 1 times 10, I have 2 zeros, and then this one goes up and I get 10 to the minus 2. This is seconds. Now I know that the minus 2 is 2 decimal places, so I get my period, so 1, 2, and my decimal place. Or if I want, I can write 10 milliseconds. And problem solved. So I can go and I erase my auxiliary graph because I don't need it anymore. And this is going to be your answer. And let's go over the last one, which is a square wave. In red, so I have a square wave. The duty cycle is 30%. So that means that if I design the period, I'm going to have this part needs to be bigger than the part that is on, needs to be bigger than the part that is off by 30%. Okay, design my axis. I know I have a duty cycle of 2.5 volts. So I know that my volt peak to peak is 5. I know that my signal is going to be between 2.5 and minus 2.5. So in that case, my minus 2.5 is going to be shifted up by 2.5. So that means now that my axis is going to be aligned here. This is my time. This is my voltage. This is 0 volts, and the top of it is going to be those 2.5 plus the offset, so 5 volts over here. This is going to be my period, my T, and hopefully this one is going to give your duty cycle of 30%. We need to calculate that. So let's calculate that information. So we have my period is equal to 1/1.6 kilohertz. Different ways of solving this. You can go 1/1.6. The kilo is 10 to the third. 1.6. That third goes up to the minus third. So my period is equal to 1/1.6 milliseconds. You can also put my units over here. And if you do 1 divided by 1.6, you get around 0.625 milliseconds. Or if I move my decimal place, this is exactly the same answer, 625 microseconds.